We're going to continue looking at these kinds of graphs, the ones that have everything going, all the different transformations. And what I'm going to do is a couple examples of different kinds of questions that we can ask about these kinds of equations. My first example here says we want to find the equation of the graph passing through this point, negative 2, 2, with a vertex at negative 1, 4. Now, the way to tackle this is to keep in mind that every equation can be written in this form. This is our template. And really, all we have to do is figure out what is A, P, and Q, and that's what distinguishes one equation from another, those three numbers. Well, when you read that the vertex here is here at negative 1, 4, that's two of your numbers right off the bat. So now what we have is this. Well, we don't know A, but we do know that we want to shift the whole thing 1 unit to the left. So we want to put in plus 1. And that has the effect of shifting it 1 to the left. We also know that our vertex is up 4, so we want to shift the whole thing up 4. So we know that Q has to be plus 4. So we've got 2/3 of our unknowns right off the bat. The other information that's provided is that it passes through the point negative 2, 2. Well, we have everything here to find out what A is by plugging in the value negative 2 for X and 2 for Y. Put them into here, so I'm going to put in 2 for the Y. Don't know A. X is negative 2. Well, all I have to do now is solve this equation for A, and now my work would be done. So what are we going to do? Well, we're going to do negative 2 plus 1 is negative 1, when squared is just 1. So 1 times A is A plus 4. And we'll subtract the 4 over to this side. So A turns out to be negative 2. So here's what our equation now looks like. All we have to do is go back and say, yes, we know what A is. A turned out to be negative 2. And there's the equation that describes the graph that passes through negative 2, 2 with a vertex at negative 1, 4. Not too bad. This is our answer. Okay, let me do one other example. And in this example, we're going to put a bit of a context in. Often, quadratic equations describe objects flying through the air. And the kinds of graphs we'd be talking about typically have this kind of a look to them. This is time, and this is the height. And they'll give some kind of units. This might be time in seconds or minutes or whatever. And this would be height in meters or feet, depending upon what you prefer. The kinds of graphs that usually we see described are things like a rocket flying through the air. So perhaps at time 0, the rocket is on the ground. So we would expect to see 0, 0. And then the rocket, as time moves on, goes higher and higher, reaches a maximum, and then returns to the Earth. And at this point, it has returned to the Earth. What the question would be asking is, what is the maximum height of the rocket? Might ask, when does that occur? Now, that kind of a question is really asking you to find the vertex. Because the vertex here, that is precisely the maximum or highest point of the rocket's flight. So this point here, let's just give it some numbers. Let's say this was 5, and let's say this was 10. We could say at 5 seconds, the rocket has reached a maximum height of 10 meters or something like that. Okay? So now what I'm going to do is give you an actual equation that models the flight of a rocket. We're going to still try and answer the same things like what is the maximum height and when does it occur. Okay, so in this example we have something that looks like this. H of t equals negative 4.9 t squared. Not t squared. Bracket t minus 5 squared plus 124. Now, this may look a little bit more complicated than previous examples. You'll notice, oh my gosh, it's got a decimal number here instead of a whole number or a nice fraction. No problem. Oh, and this h of t, that just means the same thing as saying the height at a certain time. So I just interpret that as saying, okay, this is the height given at a moment in time. Well, what do we know about this graph? If I were going to draw a picture of it, I would know that I would want to shift this thing 5 units to the right. So I would want to go 1, 2, 3, 4, 5. And then this plus 124 means I want to shift the whole thing up 124. Now I can't graph that here, so what I'm going to do is just say that is 124. That's where my vertex is. Okay. The other information, well, I know that this is a negative number out front, which means it'll open down. And as far as the 4.9 is concerned, well, I'm not going to try and draw a perfect graph here. What I recognize is that that is going to be a maximum point. Exactly what the shape of the graph is isn't really important to us. We would like to know what is the maximum height of the rocket. Well, that's pretty easy to see. Maximum height we see is 124, probably meters. When does it occur? Well, at the 5-second mark. So just by being able to recognize how a graph behaves, we're able to identify right off the equation when and what that maximum height is. And that's pretty much, I think, all we're going to do as far as talking about graphing quadratic equations at this time. So we'll catch you later.